Let us discuss tutorial 3.1 part 2, part 1, question 8. In this question, there are two monochromatic light sources, P and Q. We know that the amplitude of P is not the same as the amplitude of point Q. It's a very interesting question. So the two waves meet and superimpose at point S on the screen. So in A, right, using the principle of superposition, describe and represent maximum intensity at point S at this point. Okay, principle of superposition states that if, let's say, source 1, this is a wave of source 1, and this is wave source 2, right? So the amplitude of source 1 is going to meet with the amplitude of source 2 to give you a condition of constructive interference, where the two amplitude of source 1 meets and add up together to give you a resultant. So if this has a magnitude of 5 Newton per Coulomb, the electric field, and the electric field of S2, which is 5 Newton per Coulomb, so the resultant will be total of 10 Newton per Coulomb. Okay, so that is the principle of superposition. Okay, for question B, using the information above, deduce the maximum electric field of Q naught. Okay, let's look at this. When the two wave comes out, P and Q, the first condition is if the phase difference between them is 0, they are going to interfere constructively at point S. And from the principle of superposition, the two waves add up to give you a resultant electric field of 14 volts per meter. So in this case, I write the wave amplitude of P naught plus the amplitude of Q naught. When they meet up together, they are going to give you a resultant of 14 volts per meter. Okay, the second condition is if these two waves are having a 0.5 lambda difference between them, right? The initial phase difference between P and Q is 0.5 lambda. That means they are out of phase by half a wavelength. So when they meet up at this point on the screen, the resultant electric field in this case will be 4 volts per meter. So how do I write these things? I write P minus Q naught equals to 4.0, right? 4 volts per meter. That means basically the intensity of the light is going to reduce, and we don't get destructive interference simply because the two waves do not have the same amplitude. If the two waves are having the same amplitude, then we are going to get a condition that's known as destructive interference. However, since they are not of the same amplitude, we get a reduction in intensity. So the intensity drops to 4. So the question is, what is the amplitude of Q naught? So there are two simultaneous equations, equation A and equation B. So solving this, we can A minus B, what we get will be 2Q naught equals to 10. So Q naught will be having of 5 volts per meter. So the amplitude of Q naught is 5 volts per meter.